Hi, Chem students. Welcome to your very first lesson in chemistry over measurement. Please have out your notes and something to write with. This is a friendly reminder that because this is a recorded lesson, you can always press pause and raise your hand at any moment to get clarification from your teacher. Also, remember to utilize the rewind button if you need to hear something a second time. Okay, let's get started. So it's important to mention that measurement is going to be the basis of this class. We're going to use everything learned in this entire unit throughout the entire year. So it's really important that everything is mastered and that you don't lose anything along the way. So please ask really good questions as you have them. So why is measurement so important? Science is all about observing and experimenting. We need a way to add relevance to our observations and experiments. So we use measurements to collect and express our results. Without these measurements, we would not be able to make conclusions or validate our results. Measurement is one of the most important things in chemistry. Without it, one can mix the wrong amount of chemicals and cause dangerous situations. For example, in real life, if a patient is given the wrong amount of medication. Okay, so there's different systems of measurement. Two of the most common ones in the world are the U.S. customary system of measurement and the international system of units, commonly known as the metric system. The majority of the world uses the metric system, including the scientific community. So in this class, we're going to use the metric system. So you're more familiar with the U.S. customary system, but I'm going to try to get you comfortable with the metric system. Okay, so when measuring mass, in this class, we're going to use grams. You're more familiar and comfortable with things like pounds and ounces, which is the customary system. Okay, for length, in this class, we're going to use meters. For volume, we're going to use liters. And for temperature, we're going to use degrees Celsius. Okay, scientific measurement is all based on the metric system, which uses powers of 10, so it's easy to convert between units. So if we look at the metric system, here are our base units of grams, meters, and liters. As we move to the left, our units get larger. All of these guys are called prefixes. So deca, hecto, kilo, mega, and giga. So you'll have decagrams or hectograms or kilograms, etc. Going to the right, our units get smaller, deci, centi, milli, micro, and nano. So nano is the smallest, whereas giga is the largest. So giga, you may have heard of a gigabyte. A gigabyte is a large amount of memory that you can store or have on your computer. But when you get to nano, that's really small. So here's a good example. It says, in the time it takes to read this sentence, your fingernails will have grown approximately 1 nanometer. You will need to memorize the order and meaning of prefixes from kilo to milli. If you need other units, they will be given to you. So we have a little mnemonic that's going to help you to memorize this. It's King Henry danced before drinking chocolate milk. So King goes with kilo, Henry goes with hecto, danced for deca, before is our base unit, drinking is deci, chocolate is centi, and milk is milli. Okay, so when we're talking about the size difference, I want to emphasize that our base units here are considered 1. As we move to the left, we get 10 times bigger. So deca is 10, hecto is 100, and kilo is 1,000. So this is how much larger it is than our base unit. When you move to the right, you're getting 10 times smaller. So deci is 0.1. Centi is 0.01 and milli is 0.001, so 1,000th the size of our base unit. Okay, so in our class, we're oftentimes going to need to convert between different units. And in order to do that, we need to have our metric system memorized. So I'm going to use that saying in order to write down the order of our units. So King Henry danced before drinking chocolate milk. And you'll notice I have 2 that start with a D. That's why we say danced, because danced is D-A, and drinking is just D. So D-A for deca and just D for deci. Please do not get those confused. Okay, so I'm starting here with 45 centimeters, and I want to know that's equal to how many millimeters. So centimeters is here on our metric system, and milli is one place to the right. So I'm going to decimal hop in order to convert. I'm going to move my decimal one place to the right. So 45 has the decimal here. I'm going to move one place to the right, fill in that space with a 0. So 450 millimeters are equal to 45 centimeters. Okay, the next one. 750 milliliters is equal to how many liters? King Henry danced before drinking chocolate milk. I'm starting at milli, and I'm going to a base unit of liter. So I'm going to move 1, 2, 3 places to the left, and that's how I'll move my decimal. My decimal's here, 1, 2, 3, so my answer is 0.750 liters. Okay, so I'm starting with decagrams and going to grams. So again, King Henry danced before drinking chocolate milk. Starting at deca and moving to my base unit. So one place to the right, my answer is 40 grams. Okay, so at this time I would like you to pause the video and try the rest of these on your own. When you return, I'll have the answers for you. If you're lost and you don't understand, this is a great time to raise your hand and ask your teacher for help, but please try it on your own first. Okay, welcome back. I'm revealing the answers, so please check your work to see if you got these correct or if you missed any. If you missed any, raise your hand and ask your teacher why you missed them, or your neighbor can also be helpful. But please do not move on not understanding what we just did. Okay, so the next thing we're going to cover in this lesson is scientific notation. Hopefully this is a review, but I'm going to help you out anyways. It says you will encounter very small and very large numbers in chemistry this year. Scientific notation is useful for expressing these numbers. For example, instead of writing this really, really tiny number, we write 5.6 times 10 to the negative 9th power. Here are the rules for expressing numbers in scientific notation. Okay, first, we're going to move the decimal so that there's only one non-zero digit to the left of the decimal. That means our number should be between 1 and 9, okay? So with this number, I put my decimal here so that it's between 1 and 9, 5.6. We're going to express the number times 10, so 5.6 times 10. Then we're going to count the number of times we had to move the decimal, and that is our exponent, or our power of 10. So I had to move it 1, 2, 3, 4, 5, 6, 7, 8, 9 times to get the decimal between the 5 and the 6. That is my power of 10. And then lastly, it says if the decimal was moved to the right, the power or the exponent is expressed as a negative number. If the decimal was moved to the left, the power of 10 is expressed as a positive number. Okay, I find these last two to be a little bit difficult. So what I tell kids is that when you look at your number, if it's a really small number, your exponent is negative. If it's a really large number, your exponent is positive. Okay, so let's convert some of these to scientific notation. Our first number, the first thing I notice is it's a large number, so it's going to have a positive exponent. The next one, positive exponent and positive exponent, because they are all large numbers that are greater than 1. Over here, we've got small numbers that are less than 1, so my exponent will be negative. I've got 56,000. So my decimal is here, and I'm moving it 1, 2, 3, 4 times. So it's 5.6 times 10 to the 4th, and it will remain positive because it was a large number. Over here on the right side, I'm moving it 1, 2 times. So you get 9.5 times 10 to the 2nd power, but it's negative because I started with a small number. Okay, once again, I want to give you the chance to try these on your own. Pause it, and when you come back, I'll have the answers for you. Okay, welcome back. Please check your answers to see if you got these correct. If you missed anything or you don't understand, ask your teacher for help. Hopefully you got them all right. In this next section, we're going to do the opposite. We're going to convert from scientific notation to standard notation. So we're taking them out of scientific notation. So the first one, I've got 6.67 times 10 to the fifth power. What I notice is because my exponent is positive, this is a really big number. So I'm going to move the decimal in a way to make this number larger. So let me show you. 6.67. If I move my decimal to the right, 1, 2, 3, 4, 5, and I fill in these blank spaces with zeros, I end up with 667,000, which is a big number. But if I start with 6.67 and I move my decimal 1, 2, 3, 4, 5 places to the left and fill in those spaces with zeros, I get 0.0000667. So the top one is big and this one is small, right? Which of these is correct? Well, because my exponent is positive, this one is correct. So my answer is 667,000 because of the positive exponent. On the right side, I have the opposite. I've got negative exponents. So these indicate small numbers. So I've got 2.25 times 10 to the negative fourth. I'm going to move my decimal 1, 2, 3, 4 times to the left. Fill these in with zeros in order to show that this is a small number. So 0.000225 is my final answer. Again, at this time, if you'll pause the video and try the remaining ones on your own to see if you understand. Okay, welcome back. Here are the answers to the remaining examples. Check your work to see if you did these correctly. So the one that I anticipate you may have some issues with might be this one. So any number to the power of 0 is 1. So what this one is really saying is 5 times 1, which gives us an answer of 5. So again, any number to the exponent of 0 is equal to 1. Okay, so this concludes your very first chemistry lesson. Yay, you survived. At this time, you can turn to your chemistry teacher to see what he or she wants you to do next. I hope you enjoyed this and you found it to be helpful. Have a great day, and I know you're going to do great in this class.